This is Precalculus lesson 6-4. Today's date is January 17th. It is a digital day, which means you're either at school or you're not, but either way you're listening to this video. If you have access to a printer, please print out the notes that are available on Google Classroom, and if not, these notes are still going to be due, but they will be due on Monday. The homework, regardless, is going to be due tomorrow. Alright, so let's get started. Vocabulary. Dependent. Dependent means one probability affects the other. So I guess when one event affects the probability, I'm just going to say probability like that, of the other event. Alright, so that means you'll do the first probability that isn't affected, and then the second probability is now affected. So let's look at an example. Example 1. In a class of 16 students, 6 know how to snowboard. If Mr. Sindel chooses 2 students, what is the probability that both of them know how to snowboard? Well, when I choose the first student, it's a pretty straightforward probability. 6 out of 16 knowing how to snowboard. So it's going to be 6 out of 16. And then I'm going to choose another student after that. So it's this student and another student. Do you remember what and means? Is it multiply, divide, subtract, add? And means multiply. So I'm going to multiply this by the second probability. Alright, well, after I've chosen a student, after I have done this probability, now I have chosen one of the students, and the chance of that happening is 6 out of 16. After I've chosen a student, now how many students are there to choose from? There's not 16 anymore because one of them has already been chosen. So now there's only a pool or a sample size of 15. And has the numerator changed also? I've chosen one of the snowboarders, so there should be one less snowboarder. There are only 5 to choose from. So I have a 6 out of 16 chance of choosing the first snowboarder and a 5 out of 15 chance of choosing the second snowboarder. This is an and because it's multiply. I'm going to reduce these fractions and then I'm going to multiply. So when I reduce the first fraction, divide the top and bottom by 2, it's going to be 3 over 8. When I reduce this other fraction, the second fraction, it's going to be divide the top and bottom by 5. You get 1 out of 3. When I multiply straight through, I'm going to get, I'm going to get 3 times 1, which is 3, and then 8 times 3, which is 24. And you might have seen right away, oh, you have a 3 on the top and 3 on the bottom, and that cancels out. That's the same thing as reducing this fraction, and it reduces to 1/8, which is our final answer. Box it. So the key thing here is we really have a new step. You're still doing an and, you're still doing multiplication, but your new step, if they're dependent, if one event affects the probability of the other event, then remember to, maybe I should do this in blue. Remember to update probabilities. I was going to say maybe probabilities after the first probability, but just remember to update the probabilities. So this one we didn't need to update because it was the brand new problem, but this probability we did have to update because we chose a student from this pool and from this pool, and that's why it changed. So just remember to update them. Let's do another example. So Riley's going to grab some whiteboard markers. He or she, I don't know if this is a he or she. I guess if we're talking about Beck, it's a he. If it's my son, it's a he. But Riley's going to grab 2 whiteboard markers, and the box currently has 4 blue, 3 red, and 5 green markers. So I want to know the probability that Riley grabs a blue marker first, and then a green marker second. Okay, so let's do the first probability. The probability that Riley grabs a blue marker. Well, there were a total of how many markers? The total of 4 plus 3 plus 5. 4 plus 3 is 7, plus 5 is 12. There are a total of 12 markers. So there's a total of 12 markers to begin with. And what's the probability that you're going to grab a blue, or that Riley's going to grab a blue marker first? Well, there were 4 blue markers, so it's going to be 4 out of 12. And then I'm going to multiply this with my new probability. It's going to be updated because it's dependent. Well, now that I've chosen one of the markers, there are 11 markers instead of 12. And then a green marker has to be chosen second. Well, has green markers, the number 5, gone down at all? No, because blue was chosen, so I still have exactly 5 green markers. This is going to be 5. Let's go ahead and reduce this fraction on the left, 4 over 12. Divide the top and bottom by 4 and you get 1 over 3. So I'm going to multiply 1/3 times 5 over 11. You just multiply straight through. 1 times 5 is 5. 3 times 11 is, I was going to say 11, it's 33. And that's our final answer. Box it. Just remember to update that second or third or fourth probability, not the first one. All right, let's go to the back. This is our last example. It is a long one, so I'm going to read it really quick. So Captain Sawyer has a ship, the USS Pythagoras. The ship is 3 furlongs, or 3/8 of a mile, from the dread pirate Leadness. If Sawyer's ship has not been hit, there's a 3/4 chance to hit the pirate ship. But if it has been hit, then there's no chance of hitting the pirate ship. So don't get hit because you have no chance. Now let's talk about the pirate. The pirate Leadness's ship has not, or if it has not been hit, then there is a 2/5 chance of hitting Sawyer's ship. But if the pirate ship has been hit, just like Sawyer's ship, then there's no chance to hit Sawyer's ship. So, if Sawyer and Leadness both shoot each other once, and Sawyer shoots first, what is the probability that Leadness will hit Sawyer's ship? So now this is a dependent probability question compared to our notes on 6-3 yesterday, because one event might affect the other. For example, if Sawyer hits the pirate, then the pirate now, instead of having 2/5 of chance of hitting Sawyer back, he has 0% chance. It is dependent on whether or not Sawyer has hit the ship. So what we're going to do is we're going to look at this problem and say we want to make sure that in order for Leadness to hit Sawyer's ship, that's the outcome that we want. We want to see what that probability is. So what has to happen first? There's 2 events that have to happen. The first event and second event. The first event is Sawyer shooting Leadness. The ship, I should say. Got to make it appropriate for school, right? So in order for Sawyer to, or if Sawyer hits Leadness's ship, that means that there's no chance that Leadness will hit Sawyer's ship, which means that's impossible to do. So in order for Leadness to even hit Sawyer's ship, Sawyer has to miss, just by the way that this problem is outlined. So in order, and remember, Leadness will hit Sawyer's ship. That has to happen only if Sawyer misses. So for probability 1, what is the probability that Sawyer misses? Well, he will hit 3/4 of the chance. 3 out of 4 times he will hit it. That means 1 out of 4 he will miss. The inverse of this, I guess, or 1 minus this probability. So 1 minus 3/4 is 1/4. There's a 1/4 chance, and this represents Sawyer missing. Sawyer miss. Then we need to multiply that by the probability that Leadness hits. Well, Leadness hits with a chance of 2/5. There's nothing to do there, so this is going to be times 2 over 5. Okay, multiply straight through. What do we get? 1 times 2 is 2. 4 times 5 is 20. 2 over 20 reduces to 1 over 10. So there is a 1 in 10 chance that Leadness will be able to hit Sawyer's ship. All right, that concludes the notes. Go ahead and write your summaries now and work on the problem on Khan Academy. The homework is due tomorrow. Notes are due on Monday.